everybody does the work. So, good. Stacks and recursion. So this is going to be the next topic. It will take maybe it'll take almost all of next lecture. So as someone had mentioned, one of the uses of a stack, it's also called the call stack, which is used to actually implement function calls in the operating system under the hood. I'm not going to talk about the operating system concepts here. I want to give you the basic data structure and algorithms concept. And so sort of the one statement, which is like the header for this, is that any code that uses recursion can be converted to non-recursive code that uses a stack. So, I mean, this is what test 2 and the next homework are going to be about. It's about understanding recursion in stacks. Okay, so what I'm going to start with is I'm going to give you a recursive function. I'm going to write down the code over here. It's not a very clever recursive function. It's just a recursive function to print an array in reverse. Okay? And then I'm going to show how one can implement the same logic using a stack. So the idea is that there is this mirror between what the recursive process does and how you do it through a stack. And this general principle is something that you need to understand well. Right? So that is the point of this exercise. So I'm going to be even more lax on the syntax here. Right? The point is to understand the logic. So I'm going to describe this procedure that I will call print reverse. Okay? So what this procedure does is it's going to print an array in reverse, right? So obviously there are easy ways of doing this. You can just run a for loop and print it in reverse. Instead, I'm going to make things somewhat overly complicated by doing it recursion. So here's my function. I print reverse. So this is an array. Okay. So what I and j are like indices in the array. So this is a recursive function, so it has these extra pointers into the array. So I'll say if I is greater than j, then just return. If I is equal to j, then I'm just going to print ai and then return. Yes, the syntax is incorrect, but hopefully you understand what I mean. Just print the ith element of the array. So now what I do is I print reverse. Okay. Now sort of watch carefully. I plus j divided by 2 plus 1 in j. Then I print reverse a I plus j divided by 2, and then that's it, my guy, return. Okay, this is the code. So if I is greater than j, so think of it as what it does is it's getting two indices of the array. It is going to print the portion between I and j in reverse, okay, using recursion. Of course, you could do this with a for loop that just goes from j to I, but I'm doing this through 2 recursive calls. And to print the entire array in reverse, print reverse a 0, and I'm just going to write length of a minus 1. Right? This would print the entire array in reverse. So I'm going to pause now. I'll give you a few minutes to look over the code. What I recommend that you do is I'm going to give you an array of length 4. And I want you to run this code just on paper so that you understand what's going on in this. So I'll give you a few minutes to do it. Try to run it on paper, or mentally if you can, but do it on paper. Run it on this array with, so the index is going to be 0 and 3. Right? I'll give you a few minutes. Yes, no, do you understand what is going on? Okay, now I'm going to now ask you some questions to test if you understand. See, test, that word. Suddenly everybody wakes up like, what? What? Is he saying something about the test now? Right? I should just in the middle like randomly say test or homework, and then suddenly everybody wakes up and says, oh, what? Or grades, more importantly. Okay, so let's look at this function. Let me ask you a few questions. Question. If we swap the order of calls, meaning these two statements, these are two calls, suppose I swap the order. So first I do this one, then I do the second one. Then what is the output? Okay. So the first option is it prints the array in order, or it prints some part in order, some part reverse, or, sorry, let me zoom out. So it prints the array in order, prints some part in order, some part reverse, or it prints the array in reverse. Okay, so what does it do? So I'll pause for a minute, allow you to think about what's happening. Should run it on a small example and you'll see the answer. Just run it on 10, 20, 30, 40, the array of size 4. And you'll see what happens. What's the answer? Does anyone? Okay. All right. Okay, all right. Let's, okay, so forget what I was going to do otherwise. Let's just go ahead and solve this. So these calls have been swapped, right? Let's take this array. 10, 20, sorry. Oh wait, I have 2 document cameras. I can just put in, okay. So let's draw a picture. Let's just draw sort of the box trace, right? Just draw the calls that are made. So the first call is print reverse A03. That's the first call, right? So in this case, I is equal to 0, j is equal to 3. Right? That's the first call that is made. Okay, so this is going to make a recursive call to what? So obviously, okay, so I is not, okay, it's not going to return because I is less than j. What is the first call that it makes? Yeah? Print reverse A01, right? Okay, so print reverse. So I'm going to just drop the A. Instead, I'm just going to say I is equal to 0, j is equal to 1, right? So it's print reverse A ij, so it's A01. So I'm just going to keep track of what I and j are. I'm not going to write out print reverse. Okay, so that's what happened. What happens here? I is less than j, none of these run. Then what? Print reverse A00, right? Because you're going to take I plus j divided by 2 and take the floor. So the floor of half is 0. Again, I mean, technically, if you're writing code, there's no floor symbol. But if you don't put anything, then it's a floor, right? By default, C++ takes the floor. C will take the floor. Okay, so then you go for I is equal to 0, j is equal to 0. That's the next call. Then what? So what's going to happen? It's going to print A0 and return. Okay, so here's the printing here. Here's the printing. So it's going to print 10. Okay, then what? Then this is going to return. Now it has to do the second call, right? So, sorry, I wish I could maybe zoom out. Okay, that's the most I can zoom out. Maybe I can keep these side by side. Yeah, okay, that works. Kind of. Okay, so remember that when I is equal to 0 and j is equal to 1, it makes this call first. So 0, 0 is done. What is the next call? 1, 1. I is equal to 1, j is equal to 1. So what is it going to print now? 20. So you see that it's actually printing in order. This code is printing in order when you flip these. Everybody's tired, I guess. I mean, not me. I have tea, but you are. Yes. Okay, why does it go back? So think of it as the call when I is equal to 0 and j is equal to 1. It's making 2 recursive calls. This is the first call. So it waits for this call to finish and then goes to the next one. Right? So it's finishing and then returning. Yeah? You could. I mean, yeah, no, I mean, you could. This is overly complicated, right? No one should print an array in reverse in this way, right? So this is not meant to be an example of code you should write, but this is just an example of, I wanted to give you a simple enough example of recursion that's still complicated, meaning that it's small, it's doing something that you all understand, because we will show how to convert this logic into a stack, right? That's sort of the purpose. So does this make sense? So when you flip the orders, it's going to print the array in order. Okay, all right. But let's go ahead and look at the original code. So let me give maybe a slightly larger example. 1, 2, 3, 4, 5, 6, 0, 10, 20, 30, 40, 50. This is the array. I'm looking at my original code now. I'm just drawing out what you get. So first you get I is equal to 0, j is equal to 5. Then what is the first call that it makes? What's the first call? I mean, in order. Right? 5 divided by 2, floor is 2, plus 1, 3. So I is equal to 3, j is equal to 5. Okay? Five, 5. I is equal to 5. J is equal to 5. So when this happens, it's going to print 50 and return. Then the second call that it makes is I is equal to 3. J is equal to 4. And then it's going to go down here and do I equals j equals 4. It's going to print 40. Here it's going to be I is equal j equals 3. Then this returns, then this returns, and then the next, so on and so forth. Okay? So you see that there is a tree, which is the recursion tree building. Now what I want to do is to just replicate this logic in a stack. Okay? So here's my stack. Okay, so the way that I'm, what's the best way I should do this? So what you should imagine is so there's, unfortunately, there is some tail recursion here, so it gets a bit, okay. So we initially start with this I is equal to 0, j is equal to 5. It makes 2 calls. So I'm just going to push the arguments onto the stack, like sort of as a block. So you'll see what I mean. So I'm going to say there are 2 calls made. So the first call, as we saw, is j is equal to, The next call you'll see is I is equal to 0 and j is equal to 2. Okay? So imagine that the first thing that you do is you push both of these onto the stack, just like these blocks onto the stack. Then every time you look at the top of the stack and push its calls onto the stack. And you keep doing this process. Okay, so let's see. So the first is I'm going to push I is equal to 0, j is equal to 2, and I is equal to 3, j is equal to 5. So I'm pushing these onto the stack. So just think of these as like objects. If you really want to formally think of it as like an object, in your operating system, it's like all local variables. It's this entire this is the call stack. But for us, it's just enough to look at what's happening here. Okay, so this is what I push onto the stack. So when I run a procedure, I push its calls onto the stack. Then I look at what's at the top of the stack, remove it, and push its calls onto the stack. I'm going to keep doing this process. And when I get the base case, when I get a base case, I would just print and I would return. And you'll see that if I do this process, what I will get is the same behavior as this tree that I described here. Yeah?
Since we're pushing the 0 to 2 first, does that mean that's the printing in normal order version?
No, good question. So actually, because a stack is last in, first out, you kind of, this is the reverse one, because you're processing 3, 5 before you process 0, 2. Right? So you're pushing in order of calls. I'm sorry, you're pushing in reverse order of calls. Does that make sense? You're pushing in reverse order of calls. Okay, does that make sense? For those of you who know what tail recursion is, tail recursion makes this sort of a little different from your typical call stack, but don't worry about that. Okay, so this is the stack. So remember what I said is we're going to pop the top of the stack, and we're going to push its calls onto the stack in reverse order. Don't worry, just 3 more minutes, and I'll do this again next lecture. I can feel the vibe of tiredness. It's like, don't worry about it. So there are 2 calls. I push them in reverse order. So I go I is equal to 3, j is equal to 4. And then I push I equals 5, j equals 5. I push these onto the stack. Remember, I push it in reverse order. So first I push the second call, then I push the first call. That way the top of the stack is the current thing that I'm looking at. Okay, now I have this, so I pop this off the stack. I equals 5, j equals 5 is a base case. So I would just print in return. So this is going to get removed from the stack, and I would print 50. Then what happens is I now pop, I look at this, I remove it, and I push its calls onto the stack in reverse order. So then I would get I is equal to 3, j is equal to 3, I is equal to 4, j is equal to 4. Then I would pop this off the stack, I put 40. This is a base case. I pop that off the stack, I print 30. Then I look at this, I would remove that and push its calls onto the stack, so on and so forth. Right? So, it's a bit much, but what I recommend is to go back and look at it and try it yourself on paper. And it should be, well, okay, first study for the test, but then also do this. I give lots of work, sorry. But the point is, there are sort of 3 representations of recursion that I've given. First is just the code. The second is this tree that I've built. And the third is the stack. And the stack and the tree are basically the same thing. So this correspondence is what I want to sort of explain and teach. Okay? So let's end here.